Tuition Mobile, quality e-learning experience on the go.
Hello and welcome to today's class. For this class we shall continue from where we stopped on our probability class, and we'll be discussing the laws of probability. And then the addition law has it that if an event can have one of n possible results, okay, and the respective probabilities of these results are the respective probabilities of these results as given below: P1, P2, P3 until P, the last event. Then P1 plus P2 plus P3 plus till when you get to Pn is equal to 1. Alright, this is just trying to say that the sum of all probabilities will always give you 1. Okay, that is, if P1 is the probability of a result and P2 is the probability of a result, and then P2, P3, P4, they are all probabilities of a result, then the probability that the result is obtained should be equal to 1. Okay, the summation of the probabilities is a probability that a particular event occurs. I think that's all you're trying to say. And we'll pick an example. We pick, for example, we have that a die is tossed. Okay, all we are saying is that basically the addition law of probability states that the P of an event occurring P of, let's say, an event P and Q, rather, let me not use U. The probability of an event P and Q occurring is equal to the probability of P, okay, plus the probability of Q. Okay, this is as good as saying the probability of P or Q occurring. Okay, we'll have probability of P occurring plus the probability of Q occurring. Okay, and so the example follows. Let's take our example 1. For this example 1, we have that a die is tossed. Okay, let's still use that of a die. We have that a die is tossed. Okay, a die is tossed once. A die is tossed once. Okay, so what is the probability? What is the probability of obtaining an even event, an even numbers rather, okay, and B, the probability of obtaining a number less than 5, okay. So how do we solve this? Alright, solution, we can solve using the laws of addition of probability, the addition law of probability. Okay, and so we have the sample space. We always have to state the sample space. The sample space X, right, is equal to 1, 2, 3, 4, 5, and 6. Alright, so therefore any X, okay, the total number of sample is equal to 6. Alright, the probability of obtaining an even number, okay, is given that the even numbers in the sample space are even numbers in X 2, 4, and 6. All right. So therefore we can say that the probability of even number is the probability of obtaining a 2 or a 4 or a 6, okay, which are defined by as the probability of 2 union 4 union 6, okay, which is equal to probability of 2 plus the probability of 4 plus the probability of 6, okay, because these are the even numbers. Alright, the probability of obtaining a 2 is 1/6, and then the probability of obtaining a 4 is 1/6 too, and then the probability of obtaining a 6 is 1/6 too. And so when we add all of them, you have that probability of obtaining an even number in the die is equal to 1/6 plus 1/6 plus 1/6, which is equal to 3/6, okay, which when we divide further gives 1/2. So probability of obtaining an even number is equal to 1/2. Okay, and so there are other illustrations that could help give a clue to how to answer these questions. So without wasting your time, we'll quickly go into the law of multiplication, the multiplication law of probability multiplication, law of probability. Okay, the multiplication law states that if P1, P2, P3 to Pn, okay, are the probabilities, all right, are the probability of success in n independent events. All right, hence we can obtain the probability, hence the probability of success, hence the probability of success in all of them, in all the events, okay, that's why I'm using all of them, okay, or you can say the probability of event of obtaining a success altogether, okay, is given us P1 times P2 times P3 times 2Pn, okay, where P1, P2, P3 are the probabilities of success in all the events, in all the n events. All right, okay, let's take for instance, remember that probability must be equal to 1. So if an event is likely to occur, the probability is defined, and then 1 minus the probability of an event occurring is the probability of that event not occurring. Okay, I only said that 1 minus the probability of an event, okay, is equal to the probability of non-occurrence, the probability of non-occurrence. Alright, so 1 minus the probability that an event occurs is the probability of non-occurrence. Alright, so let's take for example 1, okay, if the probability okay, that a man aged 60 years, okay, will survive okay, for 10 more years, is giving us 3/4, and that of a woman, and that of a woman of a woman aged 50 years surviving to surviving for 10 years too. 10 years is given us 8/9. all right, and then find the probability that both will survive. Find the probability that both will survive. All right, that both will survive for 10 more years. We'll find out the probability that both of them will survive for 10 more years. And then B, find the probability that both will not survive. Will not survive. Alright, so we can start with the first question, solution A. Okay, solution A will assume that the two events are independent. Okay, all right, and so the probability that man of 60 years will survive for 10 more years is equal to 3/4. And then the probability that the probability of woman of 50 years will survive for 10 more years is equal to 8/9. And so the probability of man and woman, okay, the probability of man and woman will survive for 10 more years okay, will be equal to the probability of man surviving for 10 years times probability of man times probability of woman, okay, which will have the probability of man to be equal to 3/4 and that of woman to be equal to 8/9. Okay, and so we carry out simple cancellations, and the 4 into 8 gives us 2, 3 into 9 gives us 3, and so the probability that both will live for 10 years will be equal to 2/3. Alright, you can write this as probability of both. Okay, alright, and so for the section B of the question, solution B, okay, we try to determine the probability that both will not survive. Probability that both will not survive. There are two approaches to this. Okay, the first approach is, just like I said, the probability of not success, or not the probability that event doesn't occur is 1 minus the probability that it occurs. So we can just subtract the probability of both. We can just say 1 minus the probability of both, which is equal to 1 minus 2/3, and then our LCM here is 3, here is 3, here is 2. Okay, so we'll have 1/3, so therefore we can say that probability of both, okay, the probability of both not surviving, probability of non-survivor, okay, will be equal to 1/3. Or we can determine the probability of both by the second method, is by subtracting, method 2, by subtracting 1 minus probability of man surviving, okay, and then multiplying with 1 minus probability of woman surviving for 10 years. Okay, this is equal to 1 minus probability of man surviving is given as 8/9. Is that, sorry, 3/4. Okay, and then probability of woman surviving gives 1 minus 8/9. All right, and so 1 minus 3/4 is given as 4 minus 3/4, okay, which is equal to 1/4. All right, and then 1 minus 8/9 is given as 8. 1 minus 8/9, we have 9 rather, minus 8/9, okay, which is equal to 1/9. So we have 1/4 times 1/9. Okay, is that what we have? Yes. All right, for this part we have 1/3, 4, okay, 3/4, we have 4 minus 3, it's 1/4. Okay, and so for this two we have 4 times 9, we have 1 4 times 9 over 1/36. Okay, so let's look at our question again, find out what has happened. Alright, have multiplication here. Alright, I'm trying to find out whether this holds to, okay, 1/3. Okay, it should have given us the same outcome on this side. Should have given us this. Alright, this does not hold, okay, because this gives us 1/36, and then it does not hold for the second method. Please do not take this method, it's wrong. Alright, and I think this will as well help you know that it doesn't really work logically for this. Okay, so the only way to determine the probability of none is by subtracting from the probability of Sussex. Okay, the probability of Sussex 1 minus probability of Sussex gives the probability of non-Sussex or non-occurrence. Thank you. Keep practicing and learn more. Catch you up in the next class. Bye.